So in this video, we're going to look at what a net ionic equation is and how to solve them. Net ionic equations are not tricky. You just need to make sure you know your solubility rules, and this typically is what we do in solution chemistry. Okay, so solution chemistry, you have solutions. In your chem lab, you mix the solutions together, and then you're going to be doing a net ionic equation, especially if you make a precipitate, okay, a PPT. All right? I think it's honestly easier if we just do an example. So we're going to need the whole page for this, all right? So if I had, usually they break it down, okay? So they'll break it down by saying, here's your molecular equation. So if this is your molecular, okay, this is your molecular equation, the first thing you want to do, that you always want to do, is balance your equation, okay? Please balance your equation. One lead on this side, one lead on that side. 2 nitrates, so I need 2 nitrates. Now I have 2 potassiums, so I need 2 potassiums, 2 chlorines, 2 chlorines. I'm good. Okay, so I've balanced my equation, and now I need to assign these little subscripts that are states of matter. Okay, so this is why you really need to know your solubility rules. So PbNO3, nitrate, all nitrates are aqueous, okay? KCl, potassium is a alkali metal. All alkalis are going to be aqueous, okay? And halogens mixed with alkalis are aqueous. Cool. PbCl2, this one is one of those exceptions with the halogens, right? It'll say halogens are soluble except when bonded to, it has a little list of them, and lead is one of them. Okay, so this is actually a solid. So if I had in real lab, if I was doing this in lab, I had lead 2 nitrate and potassium chloride and I mixed them together, I would get a solid. I would see that precipitate when I mix those 2 solutions together, okay? And then potassium nitrate is aqueous, okay? This is my full molecular equation, all right? Then it wants me to do, it says it literally 3 different ways. It'll say your total ionic, your full ionic, your complete ionic equation, whatever, okay? All means the same thing. It just means you are breaking down every single ion, okay? So anything that's aqueous, you're going to show it as an ion. You're going to show it. And do gray, okay? So this is aqueous. So lead, when I mix lead into a solution, is actually Pb with a 2+ charge, okay? And you could literally write AQ for every single thing, okay? For every single ion that breaks up. I'm not going to, just to save space. Plus nitrate. I have 2 nitrates, so I have 2 NO3 minuses. Plus, this is all aqueous, so this splits apart as well. 2 potassiums and 2 chlorines. All right? And this reacts to make, this is where we get our solid. Okay? This does not split up to be different ions. This is a solid. So lead 2 chloride stays together. This is a solid. This is a precipitate, right? Solid. All of these are aqueous, okay? These are all aqueous. This is a solid. But then I also get 2 potassiums and, running out of room here, 2 nitrates. Okay. Ugh. All right, hopefully we can see that, okay? And these guys are also AQ, okay? So this is my total ionic equation, okay? Then I want to get my net ionic equation. Okay? All that means is I'm getting rid of what they call spectator ions, okay? We're going to delete the spectator ions. Okay, that just means the ions that appear on both sides of the reaction. Okay, or that's the way that your book is going to tell you. Get rid of the spectator ions, the things that show up on both sides. What I think is easier, honestly, is I made a solid. Okay, so whatever my net ionic equation is going to be, I know that I end up making, that's a horrible color, I end up making PbCl2 solid. So I need to find the ions that made my solid. Okay, potassium is not part of the solid that I make. It's not part of the precipitate that I make. So that's a spectator. I get rid of him. I only care about the lead and the chlorine that make my solid. Okay, but if you want to follow the way your book will show you, okay, you're going to delete your spectator ions. So I have lead with a 2+ charge on my reactant side of the equation, but I don't have that on my product side. So that's not a spectator. I do actually have Pb with a 2+ charge, which is aqueous. Okay, then I have 2 nitrates on this side. Ooh, and I have 2 nitrates on that side. So spectator, they get crossed out. Okay, potassium, 2 potassiums on both sides. Spectator, he gets crossed out. Okay, 2 chlorines. Oh, nope, that's part of the solid, so I'm going to keep him in there. So plus 2, don't forget to Cl minus, like I did. That's a 2. Okay, and then you get this, your net ionic equation. You're showing that the lead cation plus 2 chlorine anions, chlorides, make lead 2 chloride solid. Done. Easy.